Last but not least, on to lesson 1.3c. As you can see in here, the major idea or the takeaway that you needed to understand in this lesson were the different exponent rules. So underneath here, I have a little note that says that these exponent rules are rules that help us simplify expressions. So for these exponent rules, they are really something that you're just going to have to end up memorizing as you get more practice with the different problems that are here in our summary notes, the different practice problems that you've already done for me for lesson 1.3c, and more practice problems to go back to as you review and prepare yourself for your next summative assessment coming up. So again, I'm going to show you how to apply these rules. In the notes video, I had you try and think about them a little bit more deeply in order to help you memorize what you had to do for each of these rules. But basically, the more practice you get, the more you're going to memorize these rules and remember them for the future, because they will show up when you start simplifying more challenging expressions, and they will start to show up when we start moving along in our concepts and skills that we're going to learn in the future. So the first major rule I need you to know and understand is called the product rule. So if we look here, I have two different examples, and for all of these, I try to give examples that just use numbers, and then I try and give examples that have variables involved too. So with the product rule, if you notice, for 5, 6 times 5 fourths, first of all, product means an answer to a multiplication problem, so hence this is a multiplication problem. And I can see that in my two things that I'm multiplying, or my two factors that I'm multiplying, I have the same base. So 5 in both cases is my base, and then I have two different exponents. So anytime that you have the same base, so underneath here, I'm going to write multiplying same base, dot, dot, dot. So anytime you notice you're multiplying the same base, you need to add your exponents. So this is a nice little reminder about what you need to do with the product rule. Therefore, for 5, 6 times 5 fourths, I'm going to keep my base of 5, but I'm going to simply add the exponents of 6 and 4 together. So 6 plus 4 is 10, therefore this expression simplifies to 5 tenths. Now, a couple of things. I know in my the notes that I gave you for lesson 1.3c, I had you do some expanding work or expanded work around this so you can clearly see why this property works. So don't forget that you can expand this out and actually write out 5 being multiplied 6 times, and then write out 5 being multiplied 4 times, and you'll see that when you count them all up, you'll have 10 5s. Hence, we get 5 to the 10th, or that's why you add the exponents together. Because I'm running out of space and time, I'm just not going to go through that expanded form or that expanded notation. Second thing, I know that you can type into a calculator to help you find out what 5 tenths is. It's going to be a really, really huge number. But the purpose of using these exponent rules to help you simplify expressions is just to not have to really rely on your calculator or rely on mental math to help you actually figure out these solutions. The only time I'm going to ask you to actually figure out what something is to an exponent is if it's an exponent of 2 or 3. Anything higher than 2 or 3, you can just leave in this form. So again, here in this example now with variables, I have the same base. So I'm multiplying the same base of y. So I'm going to keep my y base. And I'm going to simply add the 2 and the 9 together. So this expression with the product rule exponent rule is y to the 11th power, or the 11th exponent. Next rule is called power of a power. Now, the reason why this is called power of a power is because if you notice inside both of my parentheses, I have a number or a variable being raised to an exponent. So that's what we call a power. And then there's another power or an exponent out back, or that it's being taken to. So we have two different powers or two different exponents in here and only one base. So anytime you have one base with two exponents, So that's my little note at the bottom. One base with two exponents. You are going to multiply your exponents. So in the first example, I have 3 squared to the 7th power, or the 7th exponent. So I'm going to keep my base of 3, but I'm simply going to take 2 and multiply it to 7. So 2 times 7 is 14, so this becomes 3 to the 14th. Same thing in my example below. Here I have c to the 4th and then to the 6th exponent. So I'm going to keep my base of c and simply multiply 4 times 6. So then keep c, and 4 times 6 is 24. So this answer, or simplified version is c to the 24th. Third rule is called the quotient rule. So the quotient rule, if you notice, or you will end up seeing, is slightly or the opposite of the product rule, which we talked about first. The quotient rule, I have 7 as my base in the numerator and 7 as my base in the denominator, and I just have different exponents. So anytime you have the same base and you're dividing, because remember, dividing two things and getting the answer is called the quotient. So anytime you have the same base and you're dividing, you need to subtract them. So my little note here is when you are dividing the same base, dividing same base, you need to subtract your exponents. So when I look at 7 to the 11th divided by 7 cubed, I'm going to keep the base of 7, but I'm going to take my top exponent and subtract my bottom. And that's something important to remember as well. We always take top, subtracting the bottom. Numerator exponent, subtracting denominator exponent. So again, keep 7, and 11 minus 3 is 8. So my simplified answer is 7 to the 8th. Same thing with my next example. My same base is p, so I'm going to copy p. And here I have 5 minus 12, because again, I'm going top exponent minus bottom exponent. So for this problem, I have p. Now 5 minus 12 is going to give me a negative answer, and that's going to be negative 7. Technically, I can go further with this problem, but I'm going to stop here and call this my solution for now, because I'm going to show you how to go further with this type of problem when we get into the negative exponent rule. All right, fourth exponent rule is called the zero exponent. This is really nice. Basically anything, so any number, any variable, anything in general that is taken to the zero exponent, as you can see here, and it can be multiple things like 500x. So remember, 500x means 500 times x, and you can see that all of that, based on the parentheses, is taken to 0. Anything to the zero exponent is 1. So anything to 0 equals 1 is my little note. Therefore, my answer here is simply 1. Anything to the 0 exponent is 1. That can be a variable, that can be a number, that can be a number that's a fraction, a number that is negative. Anything to the 0 exponent is 1. Finally, the negative exponent. The negative exponent, I need you to think about in terms of reciprocal. So I'm going to write a little note that says take the reciprocal. And if you think about the word reciprocal, remember that means switching your numerator and denominator. So thinking of a fraction, you're taking the reciprocal. In the first example, 8 to the negative 4, or any whole number, technically is always or can always be written over 1. So in this example, I have 8 to the negative 4 over 1. So again, any number, I can make it look or write it in fraction form by placing it over 1. I'm going to go ahead and stop here for this video, and I will finish the last two examples in our last video.